Hello friends, let us discuss the quality control of concrete. Now, as we are seeing that the concrete is a mix of various substances like the cement, aggregates, water, admixtures and SCMs, secondary cementitious materials. So all the properties of ingredients of concrete will definitely have the effect on the resultant concrete. This is for sure and very important to know. Though it is a very common sense, people are always careless whoever are involved in concreting operations on the site. Right from the laborers, the supervisors, up to the site in charge or sometimes the quality department. Because every mix of concrete, every time, every stringent parameter is required to be monitored. Stringently it is required to be monitored. Means the people who are involved on the site in making concrete, casting the concrete, curing the concrete, finishing the concrete, all these people, even though if they are changing every day, laborers may change. Therefore, it is very important on the part of the site in charge, on the part of the quality control engineer to look after the quality. Because if it is in the making of concrete only utmost care is taken, then the problems further of either the honeycombing, cracking or less strength development, less durability, less sustainability, many further complications will be not at all there, minimized. We have seen also that concrete has two states. One is its fresh state and the other is its hardened state. So in the fresh state, it is more controllable. Quality of concrete can be more controlled in case of this fresh state. After the hardened state and after 2 months, 4 months, years, we cannot have any other method to control or to maintain again or to regain the quality. Afterwards, if there are certain defects, cracks, surface appearances not aesthetic one, then we may go for the repair works. But in case of fresh concrete, yes, there is opportunity with the site people that they can control the concrete at every stage of its make. Now, we have seen so many operations in concreting like the mixing, then transporting, then placing, then compacting, then finishing, curing, all these operations we have seen. Every process has minute detailing. Actually speaking, specifications in the contract may not be that detailed written, but the owner or the client may expect something which is called quality. Therefore, let us first of all see what exactly quality means. When we try to define the word quality, it is really difficult. We cannot say which is the best tea. Suppose there are 10 different hotels giving you tea for about 7 rupees, 10 rupees a cup. Then which is the best quality? Again, it is subject to variations. Somebody may like more amount of sugar in it and somebody may like less amount of sugar. For both of them, the quality is different. And therefore, Here, specifications play an important role. What is the work or what is the job? Which type of concreting is to be done? Is it a dam? Is it a tunnel? Road pavement? Skyscraper building? Bridge? And therefore, the grade of concrete, which defines the strength measure parameter which we understand from the grade of concrete, is strength, that can be achieved. But quality is again a complicated term. Means when entire life of that concrete, 100 years, 75 years, the strength of that concrete should be maintained. There are tests which can be called non-destructive tests, which we go for hardened concrete state and then try to destruct the concrete in case of fresh concreting, and in case of the hardened concrete, whenever the existing structure is there, we don't want to destruct the structure, still we want to measure the strength of it. That is non-destructive testing type. In that we can measure the strength year by year, and then if it is giving fairly the same values, then we can say the quality of concrete when it was being manufactured, made, is probably good. Again, this quality in case of concrete, good, poor, fair, these types of word you will be finding that they are used, which actually is again, all these words, they are subjective, they are not objective. Objective means we should have a quality defined in terms of some measurable thing. Means 1, 2, 3, 4, 5. On a scale of suppose 5, rate this concrete. 5 being the highest, 1 being the lowest. Then we can say 3 is the quality of concrete, 4 is the quality of concrete. So how can we define the quality of concrete? Therefore, what is quality is very important to be defined. Contract documents, in that specifications, there are clauses that concrete should be so that it is possessing workability by this method this much, by this method this much. Like that, various properties of concrete, the compressive strength, then the tensile strength, flexural strength, all these strengths will be measured in the laboratory. There will be also a cross check if at all possible by the client, and then they can say the quality is satisfied or satisfactory. The surface finish, no cracks, no honeycombing, aesthetics, means we have to be very specific about every aspect of concrete which is responsible for providing quality to the concrete. So strength is one thing, then the durability, and that durability is not just for that much time up to which that site was going on, and after the construction of that project is over, then the contractor has nothing to do. This is not the case now. Nowadays people are more and more being learned, getting learned about all these things, and therefore that contractor, for example in case of concrete road pavements, the contractor companies, they are required to maintain the road for about 20 years, 25 years. Clauses are now becoming stringent in that document. Specifications are required to be very well studied by the concrete engineer, site in charge, the company, and then they have to execute a very good quality control on the site. And hence you will find in most of the big companies you have quality control, quality assurance department. Means even if the actual work is being undertaken, I can give some guidelines to the team of concreting right from the laborers up to the in charge, supervisor or that casting in charge, that do this. So we have to enlist do's, we have to enlist don'ts. In do's we can have some 10-15 items. In don'ts also we can have some 5-10 items. And it's a checklist. So that checklist we can have every day monitored by this QA/QC department. Means, for example, whether you have tested a fresh received lot of cement. Cement testing is done, and whether that results or the test results are satisfactory. Where is the report? Cement can be tested also on the site, field test. Laboratory can also be there on the site, laboratory tests. Then aggregates similarly. Every day we have to go for bulking of sand, bulking of aggregates, moisture content determination, and depending on that we have to measure the bulking and alter the water content. Means the mix design is saying that this much is water cement ratio or water binder ratio, but on a particular day, because of the bulking of aggregates, we have arrived at this particular water content or water binder ratio. This is quality controlling. And when we have all these norms or guidelines set for achieving quality in the concreting, we say that it is a quality assurance. Hence, training important, very important. Training is so important in case of concreting. People who are in the lowermost layer of that concreting, that is laborers, they are also required to be trained. Then the, for example, mixer operator, weigh batcher, who is pouring that cement, sand and aggregates in that weigh batcher hopper, how you are making the sequence of it. First of all, let all that cement, one bag of suppose cement is to be there, and for one bag you have calculated this much is sand, this much is aggregates. So let first of all that person put the one complete bag of cement there. Even when you are opening of that particular bag you are doing, it is having certain important instructions. People or laborers on the site, they have general tendency to cut with the hacksaw blade or some type of that cutting knife edge, and thereby cement is also wasted, and the bags also which are there after the use become useless. Therefore, cement, when it is poured into the weigh batcher, after that the sand may be put, after that the aggregates may be put. But laborers are having a different tendency. They don't wait for, there is a hopper ready for taking all this draw mix, so they will be always pouring cement and somebody comes in between and puts the coarse aggregates. Then the sand that he comes. So all this makes a mess of it. It is the duty of that supervisor there to look into this fact that the sequence is properly maintained. Then the dry mixing is also done. Then water exactly measured on that particular day. Generally, water binder ratio is calculated, and for one bag of cement, suppose you have this much of liters, 17 liter, 18 liter, 19 liter. And that becomes a perfect measurement for all the days. Actually, bulking has a strong effect on the water content. And therefore, every day there should be strictly following up of the instructions which have been received from the quality department, laboratory department. On the site, that supervisor gives the instructions to that waterman, and he that much quantity of water assures to be mixed with water. So these things are very, very important. Quality of concrete is not an accident. For that matter, in all the walks of life, quality is not an accident. Quality is a purposeful, intentional effort. It is an intentional effort that people take very much pains for that. They exert a lot. They prepare, they do some homework, they anticipate, they have a proactive behavioral approach to the control of all these things. Then one can go for the quality achievement. And again, how much quality is achieved? Not 100% all the times. But when we speak of this good, better, best, poor, fair, then again we are making some subjective statements. We should have some attempt to measure the quality. So quality should be measurable, and for that all the parameters are to be listed out which are providing quality, and therefore these parameters again have to be identified for the measurement. How many parameters of that are measurable, which are not measurable? Then if they are not measurable, what best can be done for that? So we just saw that some parameters are measurable and some parameters are not measurable. Measurable parameters, well, we can go for the tests in the laboratory and we can actually come up with the results of those parameters. The parameters which are not measurable, what best can be done for that should be discussed, and along with the satisfaction of the client, the things should be arrived at, so that after that there should not be any debate, argument or dispute. So the specifications play a very important role, and therefore requirements of specifications, they should be properly understood by the both parties, client as well as the company contractor. And then the control to have that specification in reality. That means requirements of specifications is one thing, and then secondly control requirements. So these are required to be there, which is called a written agreement again. Requirements that control requirements. For example, the client may ask for a qualified degree civil engineer as an in charge of the laboratory. He should put a condition that there should be enough testing equipment of the laboratory for cement, for concrete, for sand, for aggregates, for water, for everything. Then there should be manuals. There may be the conditions put by the client that there should be manuals, so that the standards like Indian standard codes, if it is a road project, then IRC standards, they are maintained or they are available there in the laboratory. Textbooks also relating to concrete technology must be there. So control requirements, they will be always put in by both the parties. The quality assurance and quality control engineers, they are the key elements in this quality control of concrete. They should have a thorough knowledge of the latest versions of the IS codes. They should be perfectly able to perform all the experiments that are required to be on that site for particular project. If not, suppose some costly equipment is there which is the demand of that client, the negotiations are always there and the contractor should negotiate with the client so that that particular test can be outsourced. But again, that outsourcing has certain time limit, and therefore the control is there again on that particular condition. So requirements of control, requirements of specifications. All this is very, very important quality to have durability of the concrete as well as serviceability of the concrete. These two things are very important. Durability of the concrete means it is for about 100 years, 75 years. And serviceability means there should be no fatigue, structural defect on the concrete structure. It should be always in a good condition to serve the basic purpose for which it is. So, the quality control and the importance of quality control is that the assurance of quality is required to be jotted down, and the quality control is to be really exercised so that there is no any dispute in between the two parties thereafter. Not only for that, whenever a national property like a construction of a huge structure, for example, just now we had those world popular image of Sardar Vallabhbhai Patel. If that structure is not of a good quality, durability, serviceability, then everything is going into vain. Therefore, the companies which undertake all these types of projects, they have to be very serious about maintaining the quality of the works. Concrete is being used in almost all the projects. Therefore, the quality of concrete is very, very important. Quality can be dependent on some factors. So, factors affecting quality of concrete. We can enlist so many factors. We have personal means who are the people involved in concreting. All the laborers, if they are given at least some initial training about concrete, they should be doing the concreting. They should know the importance of not having dust in sand, and for that they themselves should have also a remedy that sand is required to be washed. The size of aggregates or chip like aggregates, they should be able to, because these are all common senses, they should not use that aggregates with dust, enormous amount of dust, or shape is not up to the mark and still that is being used, or they should know that extra addition of water is going to decrease the strength of concrete, and therefore just to get my comfort of workability or ease in working with the concrete, I should not pour much amount of water, more amount of water. That much training is required to be imparted to them. The people who are actually involved in execution of quality work, they should have the procedures, maintaining the records, calculation of the standard deviations, casting the cube of concrete in the best possible manner so that the strength is calculated, strength is determined by the compression strength test. So these things are very, very important. For example, if I am to discuss, just as an example, the concrete cube casting. Generally, we have on the site concrete cube molds conforming to the IS specifications. We have 15 or 150 mm, 150 mm and 150 mm. This is the output of that cube. The concrete cube is a steel cube and it will be having 5 faces. 1, 2, 3, 4, 5 faces. The upper face is not closed one. Just like a cube has always 6 surfaces, the concrete cube is having 5 plates, one from bottom and 4 from four sides. They are required to be tightened with the nuts and bolts. Before casting, we have to apply also a lubricating oil, because that lubricating oil helps us remove the mold easily. Again, the code says that there is a perfect procedure of filling up of that mold. We have to have 1, 2 and 3 layers, and these layers filled in of about 5 cm each, 50 mm each, and then this cube is to be vibrated on a table vibrator, preferably. If there is a rodding, then again this personal error can go into it. Again, when we are deassembling first of all the cube, all 5 plates, if they are deassembled and then applied with that oil and then assembled, this is one set of operation. In another set, you are first of all assembling all that cube, all 5 plates are there fixed with the nut bolts, and then applying the lubricating oil. There will be difference. In both these cases, there are chances of having this concrete cube, these edges will not be perfect, or again when the vibrations are not in the uniform state, then there may be air voids on the surface of concrete. Now, even 1% air voids, 1% of the total volume of cube, if 1% of that volume is air void, then this is responsible for decreasing compressive strength of concrete, and that too by 5%. So just 1% of air voids volume, 1% of volume air voids will be responsible for 5 to 6% of strength reduction. Imagine that if there are 5% air voids, then 25% strength is gone, and therefore the laborers who are preparing the molds for casting, the laborers who are casting the mold and vibrating, then when that mold is to be kept in water, final set, exactly that much amount of time, and then after the curing tank, when the mold is kept into the curing tank, then getting it out of that for 3rd day, 7th day, 15th day, like that, and testing it, then only we can have the compressive strength series of compressive strength test very well done, and then there is any use of applying statistical control. So one of the control requirements of quality assurance is statistical control. If we apply statistical control with wrong execution of the procedures, then there is no any use of quality. Therefore, this is just an example of concrete cube and compressive strength of it. Similarly, we can put or set procedures for execution of control on all other requirements. Curing can be, first of all, a systematic description of that, what to do, that I told do's and don'ts, they are required to be done. Because curing is very important, placing is very important, vibrating is very important. Too much vibrations, again, where the internal needle vibrator is to be inserted, how much it should be inserted. Too many excessive vibrations will be affecting the concrete surface in which way, how to control that. There are so many discussions we can hold about everything. Even when we see the aggregates, when we perform the sieve analysis experiment, when we find out the fineness modulus, when we use that fineness modulus to either accept or reject the aggregates, cement tests, then the specific surface calculation of cement, which method you are using, fineness, so many things we have to be well versed with. Therefore, the quality assurance engineer, first of all, he should have a thorough knowledge of the subject of concrete technology. He should be having not only thorough but updated knowledge, because many codes, they are revised after a particular duration of time. Many codes yearly or every 2 years, 3 years, they get some amendments, and therefore updation of that is very much essential. And then actual latest practice of all these quality control procedures, he should be well versed with. Therefore he should be able to do that first in the laboratory. He should do it, and then he should give training to some people so that they can on the site, on a day, everyday monitoring, on the daily basis, they should be monitoring these things. That is very, very important. Now this is about that personnel. Secondly, we can go for the quality of materials. So which type of materials we are using? For example, cement grade 33, 43, 53, which are ordinary Portland cement, composite cement, varieties of cements are available. Which cement you are using, what are the specifications of that cement imposed by the client in the contract document which you are receiving on the site. Have you tested it? Have you found all those tests satisfactory with the conformation of IS code or not? So materials are also required to be of the proper quality, and then only we can expect the concrete to be of a good quality. So first we have seen the personnel, the factors which are affecting the quality of concrete. Second, materials, in which we saw that cement, aggregates, admixtures, the secondary cementitious materials, all of them are required to be of the proper quality. Specifications are always there to guide, to select the proper material. Preferably, for example, cement, if it is a 4 years or 5 years duration, a very long project of concrete, then single source is always better. Means the same company, similar type of cement, preferably having a uniform quality, not having too much deviations, that should be acceptable. Aggregates, as far as the source of aggregates is concerned, the same source of aggregate should be there. For a project which goes for about 4 to 5 years, 7 years, 6 years, may not be always possible. Then there may be little bit variations, but again the marginal variations can only be accepted. So the materials, whenever they are procured, whenever they are received on the site, for all these materials standard testing procedures should be carried out. Like on cement, we have fineness of cement, specific surface determination, the consistency testing, initial setting time, final setting time, compressive strength, making cement and standard sand mortars, and then cubes vibrating in the mortar cube testing machine, casting, testing. So the grade of cement received should be fairly the same one, uniform. Aggregates, again the same thing. Bulking we have to calculate. We have to also see the moisture content determination, specific gravity, sometimes the fineness modulus, shape, that flakiness index and elongation index. Particularly these are the tests which are carried out for shape test, shape of the aggregates. So deleterious materials should not be also there. And water, we generally say that which is potable, water which is potable, that is good for our concreting. But when we are working in the northern east areas of our country or in the seashore, and the water which is coming there may be having unwanted chemicals. So at times water should also be tested for, because water and cement reaction, when we say that cement hydration or gel reaction is there, if some unnecessary chemical also comes into that, because we expect that H2O only will be H2O, because already we have so many chemicals in the cement, and hence suppose yet another chemical is there in the water, there will be complications in the reaction. Hence water requires also to be tested sometimes. Now the admixtures, sometimes the concrete can also be used in to support with the chemical admixtures or mineral admixtures. These admixtures are required to be again of a standard requirements. Hence, who is manufacturing that chemical admixture, that source should be known. Admixtures are required not to have exposed to sun, they having a proper cover, dust should not go into that. Therefore, all these precautions are to be seen by the quality supervisors, quality assurance department. And workmanship. Workmanship is always very important. Again, from right, the mixing, placing, transporting, vibrating, compacting, curing, finishing, everywhere people are involved, and they may not be having any knowledge of civil engineering or concrete technology, and therefore whatever they think is easy for them, they may be doing it. Hence you can see, for example, the column which is of about 4-story height, means suppose 15 meter, 14 meter height, every centimeter of that concrete should be of the same quality of concrete. How can we guarantee? The straightforward statement we can do is that it is impossible. But can we allow that to be impossible only? Or cannot we go for a positive attempt to make it happen that all 14-15 meter of the concreting, every portion of that column is of the same quality, same configuration, same setting, same strength, same curing, same visible appearance aesthetically, no cracks, no air voids? How can we guarantee that? And therefore quality control is here coming into play, very important aspect. And then without any equipment we are unable to make all the concreting. We have to have mixers, we have to have vibrators, and therefore the mixer, or which is weigh batcher, for example, feeding of the materials of concrete to the mixer is with the help of a weigh batcher. Then there should be weights recorded of that particular material, cement or sand, the exact quantities, whatever is there in the mix design. And therefore the weigh batcher calibration is important to be done, which is the quality important or quality parameter. Next is that vibrations. Vibrators can be of different types. Therefore, frequency of vibrations and amplitude of vibrations, these are two important parameters which need to be checked frequently. Then only we can say that yes, our vibrators are up to the mark and we can use them. So about these four, we can say that these are the factors that affect the quality control of concrete. All in all, quality is, even if it is an abstract or vague concept, the people are making it more happen that we can have measurable indices, numbers, some sort of that which can be said, which is legible, understandable to even common man, that okay, this is like that, or this is of a first class, second class, third class, like that concrete. We can come up with certain procedures, descriptions, which will be more objective, then that we can say we are executing good quality control.